Alright, we're still on the topic, right? Projectile motion. This is the second type of projectile motion. We want to talk about the second type of projectile motion. This second type of projectile motion, animation. Okay, now this is the second type of projectile motion where we have this the projectile launcher launching from a height and launching horizontally. It launches from a height and horizontally it shoots. So in this type of projectile motion, what we're concerned about is the time of flight, the time to move from the point of shooting all the way down. Take note, this shooting takes place horizontally. So the time of flight and the range, which means the distance between the level where it's being shot to the point where it lands. This distance gives us the range of the object that moves in such projectile motion. So the formula for this time is square root of 2h all over g, where h is the height of this. Let's just have we can see the board. H is the height. Let's have a sketch of the animation. Okay, a projectile launched from this point moves horizontally all the way down. So this is the range and the time it takes to come down to this point. So this range is u multiplied by time. This u must be the initial velocity horizontally, so the horizontal component of initial velocity. So we can also write the formula for range as uxt can be replaced with 2h all over g. So now let's just take a sample question. Now we can see the question on our screen. This question says a level 5 bomber flying at 300 meters per second releases a bomb at an elevation 1.96 kilometers. How far did the bomb travel? How far did the bomb travel horizontally? Now, this could be the diagram for this question. Right, feel better doing that. So this is the bomber flying. Let's just say it's in form of an airplane. So it's flying horizontally and drops a bomb at a height. The height is 1.96 kilometers, which is the same as 1960 meters. Remember, we have to convert to standard international units. So this is the height, and we want to find the range, the distance the bomb travels horizontally. So the horizontal distance traveled by the bomb before it drops. So now, getting this, we have to use this formula. Remember, we are told that this was traveling at a velocity of 300 meters per second. So what we simply do is the range equals 300 multiplied by 2 times 91960 divided by g, which is 9.81. So if you punch this correctly in your calculator, you should have an answer of 6,000 meters. So this is how the second projectile motion question comes when we are concerned about the time and we're concerned about the range. So the third type of projectile motion, which is the final type of projectile motion, is the type that actually, let's just quickly clean up the board and go straight to our animation. Alright, now menu, animation. Alright, so this is the final type of projectile motion, where we have our height. It's not being shot horizontally, it's shot at an angle. So you can see more questions on this type of projectile motion from the King's material. Lots of questions have been solved there. Thank you very much. Important point on projectile motion is, when you have a projectile motion, the time to move upwards is equal to the time to move back down. The maximum height, the time to complete the total motion, the time to complete the total motion is 2u sine theta all over g, which is twice the time to go to maximum height. And to get the maximum range is when the theta, the angle of fire, is equal to 45 degrees. This is where we have maximum range. So these are the important points you have to take along with you on projectile motion. Thank you very much.